Hi, after seeing the explicit and recursive formula of a geometric sequence, we will see how do we find the sum of n terms of a geometric sequence. Let us try to derive the formula for the sum. We have a geometric sequence A1, A2, A3, A4 and so on and An. There are n terms, so the last term will be the nth term. It is a geometric sequence, so the common ratio between the two consecutive terms will always be R. And we have seen the explicit formula which says that to find the nth term of the sequence, an is given by a1 into r to the power 1 less than its position. So similarly, we can write a2 as a1r, a3 as a1r square, a4 as a1r cube and so on. An can be written as a1 r to the power of n minus 1. So the series in terms of a1 and r can be written as first term a1, then a1r, a1r square and so on, a1r to the power n minus 1. We want to find the sum of all these terms, all these n terms, and let the sum be s. We have to find the value of s. Okay, now there can be three scenarios. The common ratio r can be greater than 1. The common ratio r can be less than 1 and the ratio r is equal to 1. So when the common ratio r is equal to 1, sum of all the terms can be written as a1 plus a1 times 1 plus a1 times 1 square plus and so on plus a1 times 1 to the power of n minus 1. And 1 to the power anything gives us a 1. So we see that it adds up to n times a1, which is the first term. Okay, so if the common ratio is 1, then the sum of the terms is given by number of terms times the first term. Okay, now let us see what happens when r is greater than 1. When r is greater than 1, we will find s as a1 plus a1r plus a1r square plus and so on a1 r to the power n minus 1. We multiply this entire equation 1 by r. So we will have r s is equal to a1 plus a1r plus a1r square plus and so on a1 r to the power of n minus 1. So we get r times s is equal to a1r plus a1r square. R gets multiplied to each and every term in this equation. a1r cube plus and so on a1 r to the power n. This becomes our equation 2. So when r is greater than 1, r times s will be greater than s, and hence we will subtract equation 1 from equation 2. Equation 2 minus equation 1 can be written as rs is equal to a1r plus a1r square plus a1r cube plus and so on a1 r to the power n, and from that we have to subtract equation 1. Whenever we have to subtract the terms like this, we have to change the sign of the subtrahend. So all of these terms becomes negative, and when we subtract it, on the left hand side we get rs minus s, and here we see that these terms cancels off and we are left with a positive a1 r to the power n from equation 2 and a negative a1 right here. This can be written as a1 taken out common r to the power n minus 1. Okay, so we get r times s minus s is equal to a1 times r to the power n minus 1. We take out an s common, so we are left with an r minus 1. a1 into r to the power n minus 1. So s comes as a1 into r to the power n minus 1 over r minus 1. This is the formula to find the sum of n terms of a GP when r is greater than 1. And similarly, when r becomes less than 1, then instead of rs minus s, we will do s minus sr, and on simplification, we will get the value of s as a1 into 1 minus r to the power n upon 1 minus r. So this formula has to be used when r is less than 1 to find the sum of n terms of GP. GP is geometric progression, which is same as geometric sequence. So we have seen that when r is equal to 1, the sum of the terms is equal to n times the first term. Okay. Then if r is greater than 1, then sum is a1 into r to the power n minus 1 upon r minus 1, and if r is less than 1, it is a1 times, a1 is the first term, to 1 minus r to the power n upon 1 minus r. I hope this much is clear to everyone. So in our next video, we will solve some questions based on sum of n terms of a geometric progression. If you have any doubts regarding this video, you can send me an email at kirti.mathacademy@gmail.com. This is my YouTube channel, Mathacademy. If you like my videos, please don't forget to like, share and subscribe. Thank you.